Hello everyone and welcome. Today I am broadcasting you to you from my workshop. Um, so this is how life is in the COVID-19 world. So we have the screwdrivers and all my tools right here, right along with us. So then let us talk about Python programming. Here, let me just share my screen with you. And I realized the last recording probably came out a little bit long, so I'm going to try to keep this one nice and short and sweet. Today we're doing lecture 2, variables, expressions and values. So let us jump right in and get started on this. So then, you're probably familiar with the idea of working with a basic 4-function calculator. So for example, if you type 2 plus 3 on a calculator and then press the equals button, it's not surprising that 5 will pop up on the screen. So we're very accustomed to working interactively with calculators, writing an expression and evaluating that expression to get the answer. And so Python has very similar ideas, especially when we're working with it in the interactive mode. So expressions, which like 2 plus 3 is an example of an expression, they represent data. So for example, 2 and 3 could be some data points, and then we would evaluate that expression to yield a value, which in this case would be 5. Here we press the equals button, and in Python, this will be what it looks like interactively, which we'll be seeing more of in the lab, how to actually do this, but it's pretty simple. You type 2 plus 3 and you press the enter button and 5 will come on your screen, just like a calculator. So expressions and values have a few important points we should review. The value is going to be equal to the original data, but the value is expressed in what we call the canonical form. You might have heard this, for example, as the simplified form. You've probably heard of this with fractions or simplifying expressions in algebra. Python can be used to evaluate expressions. In the interactive mode, that is when we're not writing scripts in a file with Python, when it's interactive, like I've just shown you, otherwise known as the Python Interactive Interpreter, we can interactively evaluate expressions and display the result on the screen. Of course, scripts will do that as well, but we'll be seeing how we can actually make it show that result, which is with the print statement. Python is a simple expression language. That means we need to have a variety of components in order to actually express that idea. We would need to have integers and floats, which are different representations of numbers. We would need to be able to do arithmetic. We would need to have numeric comparison. We need to have this 2 different kinds of Booleans, that is the Boolean values and the Boolean logic. So let's just take a look at what those components in Python actually look like. So, you may be familiar with integers and floats from math, although you might have called them a little bit differently. Integers are the whole numbers, and they do include the negative numbers and 0 and the positive integers, and you're probably familiar with these from a sort of like a counting number line, which you probably had in elementary school. Floating point values is something that is used to represent the decimals. It is an approximation, in most cases, of the actual decimal value. So you may be aware that there's a variety of different sets of numbers. For example, the rational numbers can include the fractions, and those fractions can be represented as decimals, which is how it would be represented in Python. There's the real number set, which includes this idea that there's an infinite number of points between any 2 points, because we can express numbers with any level of precision that we wish. And we also have the regular reals. We don't really need to get into what the difference between all of these different number schemes are, but the important point here is that we could have a reason to need to represent decimals. And so in the float point values, this is how Python is able to represent numbers that need to be represented with a decimal component, and this is what we will use, which is distinct from the integer values. They will in fact actually be stored in the computer in a different way, which is why we make a distinction between those two things. We may wish to do basic operations, addition, subtraction, multiplication, and division. We'll also have a few extra ones that we'll be able to do. We'll have the floating point division, which is the typical kinds of division you're used to doing, and we will talk about floor division, but basically this is getting the whole number component, doing exponentials, or raising something to the power of something else, and also getting the remainder using the percent symbol. The expression language also includes numeric comparisons, less than, greater than, less than or equal to, greater than or equal to. We also have these expressions here, is equal to, which we use with equals equals, and this comparator here is not equal to, so the exclamation point means not, and then equal is equal. We also have the Booleans. So for the Boolean values, we have true and false values, which are in fact expressed as zeros and ones in Python. And we also have the Boolean logic. So we may want to compare between different things. So we might want to say not. So how do you say A not B, right? So we would have the keyword not. We would have conjunction for and, meaning both things need to be true. And we also have the disjunction, which is or, which means either anything that's A or anything that's B would be included. We'll definitely be seeing more of the logics when we get to doing the if statements, which we unfortunately will not be covering in the short version of Python, but we will in fact be covering that in the course. So for floating point division versus floor division, let us consider doing some division problems. So here we're going to consider 692 divided by 4. So you may remember from your math classes, 692 is called the dividend and 4 is considered the divisor, and the answer to doing that problem is called the quotient. So the single slash is the floating point division, which is regular division as you would normally think about it. So if you use the division symbol on your calculator, that's what it's going to do. The results are always going to be reported as a float. That is, it will always be reporting a decimal value, even if it's not necessary to do so. So for example, if we do 692 divided by 4, we'll get 173.0. So we notice that we could in fact represent it as just 173 and we didn't need to do the 0.0. And if you're into significant digits, we see that we would not require the 0.0 for significant figures, but this is how Python will report that. However, we could also consider 128 divided by 5, and we see that the answer is 25 remainder 3, as you may recall from doing your simple division. So in the United States, when we typically learn how to do division, or at least how I did, and we learn how to compute it first with the remainder before we learn how to make it into fractions. And so we would report this as 25 remainder 3 in the elementary schools. And so the double slash is going to carry out that floor division, that simple division, and it will tell only the whole number part of the quotient instead of the complete answer. It does not report a decimal part of the quotient, and the result is reported as an integer. So if we do the same problem as shown over here using Python, we will get the, all right, so we do 692 divided by 4, right? We'll get 173 represented as an integer because it has no decimal point. But if we do the 128 divided by floor division divided by 5, we get the answer 25, which is the whole number component of it, which of course isn't the total answer because it doesn't do anything with the 3 remainder here. So suppose you do need to get the remainder. That's where the percent operator comes in. So the percent operator is going to report the remainder portion of the quotient. So the remainder is reported as an integer. So if we do 692 divided by 4, we will get 0 because there is no remainder left over, as we saw over here. But if we do the 128% 5, we will see that we get a 3 back because that's the remainder for this. So then in order to do the complete answer to a division problem, we can use the two operators. We can, this is a print statement, which we'll learn more about coming up, but you should be able to follow basically what's going on here, right? So we have 128 divided by 5. Then we're going to do the, you're going to actually compute. So this is explicitly typing 128 divided by 5 is displaying this part. And then here we will get the 128 divided by 5 to get the whole number part, which reports to this 25. And then we put the word remainder, and then we will put in the answer for the remainder, 128% 5, which is 3. And that's how Python will print back this statement here. So we can, in fact, get both parts in order to do this. Note that the percent operator is very useful to test for divisibility. So if the dividend is evenly divisible by the divisor, the percent operator on that division problem will return 0. So this can be useful if we want to know if something is evenly divisible by something else. So we could use this for the divisibility by 2, for example. So here we can do 100% 2 and we get 0. So we say, yes, it is. But if we do 101 divided by, percent 2, we're going to get back 1 because it's not evenly divisible. So you see, we can make a very useful test. So that brings us to our Python types. So let us talk about the different kinds of types that we have in Python. So what exactly is a type anyways? Well, the different types of data have different attributes associated with them. So you could imagine that numbers aren't going to do the same things as, for example, a particular string of letters. Like maybe you have a variable that stores your name. That's going to behave differently than if you stored the number of classes you're taking at Wesleyan, which might be represented by an integer value. So different kinds of data have different attributes associated with them, and it's useful to have different types, each with their own associated actions. This is part of the object-oriented approach to programming inherent in Python. So consider storing dog and 3.14. This dog, D-O-G, is text, and this one is a decimal number. We might think about, are there other kinds of data one might want to store, and what actions might be associated with each type. So for example, doing addition with the word dog is probably not something that would be useful to define, but addition with a floating point number 3.14, multiplication, division, and so on could be extremely useful. So a more formal introduction to types tells us a little bit about how we might need to define those different things. So types are great to classify expressions. The types of an expression is always the same as the type of its value. So some types we will encounter today are integers, type int, floating point decimals, type float, strings, which is text, which is type str, str for string, and Booleans, which is true and false, type bool. How to check the type using Python? Well, you can in fact type this into your interactive interpreter or print it from your script, and you can have Python tell you. So the syntax is we use the keyword type, right? So this is a Python function, and then we put in something that we want to find the type of. So if we do type, and notice that we do need to type these parentheses, it will tell us the class int. Just let me do a quick aside. Now, when I am showing you slides, I may be showing you some examples of things to do, and so let me just make clear what my notation means. So when I put these angle brackets here, that means you need to fill in something. Okay, so the parentheses are explicitly something you should type, but you do not type the angle brackets, and you do not type expression, right? You fill in your expression. So you can watch for this when you see this kind of a typeface, which is supposed to look like typing on your computer. This is the Courier new font. So please just be aware that that's what it means when you see it. And then down here we have some examples from the actual computer. So let's also try the type of 3.14. We see that this is a float. Type of cell phone, notice that it's in quotes, that is a string. And the type of true, notice that this is not in quotes, is class bool for Boolean. So if you don't know what class it is, you can, if you don't know what type it is, you can always use this to find out. Strings is another type. It is a sequence of characters. Basically, it's text. To enter a string, what you're going to do is you're going to surround it with single or double quotes. Doesn't matter whether you use single or double, really, but you have to be consistent. So you can't mix a single quote with a double quote. That won't work, but you could do like this or like that. And strings have the type str for string. Integers. As in math, integers are the numbers with no decimal or fractional part. Set includes negative infinity to positive infinity using -2, -1, 0, 1, 2, and so on. Integers have the type int. Floats. Floats, as we've been talking about, are going to handle when we need to have that decimal part. So we see these being driven by doing division. So 11 divided by 3 is an example where, again, we would need to have a floating point. But do again note that when you do division in Python, no matter whether it will have a decimal part or not, it will be reported like this with the decimal part. They have the type float, and Python uses a decimal point to indicate that a number is a float rather than an int. So you see that if you have decimal parts after it, it's going to be a float. If it doesn't have a decimal part after it in Python, it's an int. So I would encourage you to pause the video and try out these exercises here. So go ahead and pause it, and I will see you back in a moment. All right, well, welcome back. I hope you've had a moment to look at some of these questions here. So this one is the integer, and this one is the float. Hope you got that right. Which expressions would have different type than its constituents? All right, so let's see, how did you do on these ones? I've made a little table here for you to check yourself, right? So 5 and 2 are both integers, and the answer we get is going to be an integer because this is the floor division. 7 and 5 are both ints, but we're going to get a float, so this one is different. 16.0 divided by 4.0, notice that it's 0.0. These have decimal values, so these are considered floats by Python, and you'll get 4.0 out, but it's the same. And here we also have 16 divided by 4 as int types going in, but float will come out. So this one right here, this part D and part B have different types than what the constituents were. Booleans. So Booleans have the value true or false. Notice these are not strings true or false, but they are values true and false. The symbols to evaluate Booleans are the less than or equal to, greater than or equal to, is equal to, or is not equal to. So here's some examples of some expressions, what it is in words and their Boolean values. So for example, 2 is less than or equal to 3, which is a true statement. Here is a false statement, 2 is greater than 3. 2 is equal to 2 is true. And 2 is not equal to 0. That is also a true statement. We can do Boolean truth tables, and so what we do here is we would evaluate each component of something and then find out what the answer is. So I like to think about the cookie jar. Did you ever have a cookie jar, and you wanted to take a cookie, and maybe somebody caught you taking something out of the cookie jar, and they said, are you the one who took the cookie out? And maybe you don't always tell the exact truth. So if you tell the whole truth and nothing but the truth, then that would be a true statement. But if you told partly true and partly false, the dog made me do it. An alien came down from outer space and told me to eat the cookie, and now there isn't a cookie. Well, there isn't a cookie, that's true, but is the part about the alien true? So if we have something that's true and false, that's not the whole truth, is it? The same as if we have false and true. And of course, if we fib the whole line the whole way through it, nope, wasn't me. I didn't take any cookies at all. With somebody else. If it's all false, then it's false. And so you can use this this nice little analogy to help you remember how this works. So the only way you can have some two things evaluate to true is that both of those things are in fact true. So any falsehood in a statement would cause the whole thing to become false. All right, so these are the Python types we have met so far. We have strings, integers, floats, and Booleans. So here's some examples and their types. There are many, many more types, and when we get into object-oriented programming, in fact, we will learn about creating our own types. So why are we limited to the ones that are offered by Python when you create your own? That's the great thing about learning how to program. So these are the types we have so far. And we can use those to make expressions. So compound expressions may involve expressions of different types. When the expression is evaluated to its value, the type of the value will depend on the types in the expression. We actually already saw this when we had mixed, so let's say we had, 16 divided by 4, right? Those were integers, and then something else came out on the other end. Or we could have 16 divided by 4.0, that would be mixed. What will the type be? Well, it will come out as a float. The expressions are going to be parsed in the order of operations. So examples of checking the type of a compound expression is very similar to checking the type as I showed you before. So you can do type, and then you can put an expression inside the brackets instead. So here we do 3 plus 4, which will parse to the integer 7, and it will return int. Now here we're going to have an integer minus a float, which will evaluate to a float, and we'll get float out, and this is going to evaluate to Boolean. 2 is less than 3, which will of course be true, but the the type of it is going to be Boolean, which is why it returns that. Okay, and so that brings us to the end of our second lecture. So we've talked about the different types, and we have talked about the different components of the Python programming language. So having these things in mind, now we are poised to start writing programs, which will be our topic for the next time. So now that we have completed lecture 2, I would challenge you to have a look at our MiniCourses assignment. So the first assignment, you should be able to do that now. And I look forward to seeing you to work on this. Don't forget to stop by the office hours, visit us in the Zoom meetings, and don't hesitate to reach out to me. All right, I hope you all have a great day. Thanks for joining. Bye-bye. Yes.